Hi, in this project, as the name suggests, we will be predicting the class of the mushroom, and the classes are divided onto the basis of if the mushroom is edible or poisonous. Then we will develop a web application based on this machine learning model and deploy it on Heroku. So let's understand what all we will be doing in this project. So there is this data set of mushrooms, okay, and this data set includes description of hypothetical samples corresponding to 23 species of guild mushrooms in the Agaricus and Lepotia family mushrooms. Now each species is identified as definitely edible or definitely poisonous and not recommended well for eating. Now we will be using this dataset to predict if the said mushroom is edible or not. Next, let's understand the details for the project. Now the project is divided into three parts. The first part being building a machine learning model to predict if the mushroom is edible or not. Now the second is where we will be building a web application using the framework Django. There we are going to mount this prediction model. The last part is where we will be deploying the Django project on Heroku through GitHub. Now the machine learning model. So we start off with building a machine learning model, and we use a random forest classifier model and train that model using the mushroom data points or our mushroom dataset. Now one thing to note is that this dataset has only categorical columns present. So for feature engineering and exploratory data analysis, we will be using label encoder to get the data ready for fitting it into the model. Now this label encoder actually understands about the categorical data and then converts the categorical data into a numerical representation, which then can be used later on. Now the Django web app. Now this web application is the second part of the course, and we will be using framework Django to build this web application. We will mount the model we built in the previous part of the Django project now. The last part was deploying on Heroku. So this is the last part of the course where we'll be deploy the Django application on Heroku using the connections to GitHub. Now let's start with the first part of this project where we will be building the machine learning model. So this is the first part of the project where we will be building the machine learning model for the classification of mushrooms as if they are edible or poisonous. Now you can see the first code block here is to mount the drive folder onto this collab notebook, meaning we can now access the files shared in our drive folders, and from there we can even call out those files onto the collab notebook. So as you can see, I am importing the drive package or the drive function from the Google Collaboratory package or google.collab package. And the next thing you can see is that I'm importing the necessary libraries. So most of these libraries, or I would say actually all of these libraries, are actually used for data manipulation, data understanding, or to inference more from the data, and later on go on to feature engineering or feature selection. The first library is NumPy. It is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed pretty easily and efficiently also. The next you can see is the pandas. Now this is a library for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. Now, most of you must have already understood what data structure would be given. As you can see, once I'm calling out my data, it is stored in the form of a table having all the values. And with the help of pandas, we would be manipulating the data later on. So next you can see is the Seaborn library. and the matplotlib library. Now both of these are libraries for visualization, and while Seaborn is a library for making statistical graphics in Python. Similar to matplotlib, Seaborn actually helps in exploration of your data in a much easier and with a very pretty visualization also. As compared to matplotlib, again both of these are for visualization of your data in the forms of graphs or box plots, but Seaborn gives you a lot more innovative and colorful palette so that you can perform even better or showcase even better inferences from your data, which you would be able to see later on, as I would be using the Seaborn library with the correlational graph for this dataset. Right. So as you can see now, the first thing that I've done is called out my data, that was the CSV file from the drive folder, and using the function read underscore CSV that is present in pandas, and using the head function giving the parameter as 5, I will now be watching out for the first 5 data points from my dataset. And as you can see, the first 5 data points and the first column is the class, that is our target variable, meaning this is what we will be predicting right now. Now as you can see, the dataset already has a lot of columns, and each column has some categorical data, I would say, which is pretty confusing. But here, as you can see, I have already specified what each of the letters present inside this data set means for all of the columns respectively. So you can refer to this, I would say, and from, let's say that we are taking the second column, that is cap shape. Now B means bell is the cap shape, C means conical, X means convex, F means flat, K means knobbed, and S means sunken. So now you can see that this column, that is the cap shape, has some categories of data in it, and those are represented in the form of a single alphabet, that is maybe S, K, F, X, and so on. And here it is showcased that what each alphabet means, right? And this is being done for each and every column. So if you have any doubt for any of the columns present here, you can just refer to this explanation, or I would say the full form for each of these alphabet, and see that maybe F means foul for order, but F means no for bruises, right? So even for different categories, sorry, even for different columns, there might be same category present, but the meaning for both of these category would be different. Now one thing that I missed was the shape function. So data frame dot shape would give you the Cartesian dimensions for the dataset, and as you can see, there are 8124 rows with 23 columns, including the target column we have, right? So this is fairly big data, and if you start to extract the categorical data from each of the columns, then again this data would become a lot more big as compared to now. And that is the reason where we will be using the label encoder, and you will be watching out as to how the label encoder has been used. And there is another variant, that is one hot encoding, and you will understand why one hot encoding was not used. Okay, so moving forward, so before using label encoder, we are watching out if there is a null value present in any of the columns. And we are doing this with the help of isNull function and the sum function. So the isNull function actually sees if there are null values present in each of the columns present here, and the sum function helps in calculating the number of null values present for each of the columns, right? And as you can see, there's 0 null values for all of the columns. So in that case, the data set is pretty good. Now, as you can see, I've imported the label encoder and build a simple function so that I'm able to encode all of the columns in one go, right? So before moving forward and understanding what has been done here, let's understand what label encoder is, right? So in ML models, we are often required to convert the categorical, as you could see above, that is the text features, to its numeric representations. Now it is pretty much understood that if the data is of a string type or a character type, the model won't be able to process that data. So the data in its final form should be in the numeric type, that is in the maybe long type, float type, or integer type, right? So for that, we use label encoder or maybe one hot encoder. Now, the two most common ways to do this, that is changing the text to numeric representation, is to use label encoder or one hot encoder, just like I said, right? Or its other format. Now, its other format is that there's another function that pandas has, which is dummies, right? So in dummies, what happens is that there's a function called get dummies, and that helps you in extracting categorical data into building new columns. Meaning, if there's a category, or I would say if there's a column that has three categories, right? A, B, C. So what happens is if you use the function get dummies, it would create three new columns, each for A, B, and C. And then it would depict which of the category was present for the first column using numbers like 1 and 0. So that is not what I've done here. And if you want to look more into it, you can just Google it. That is get underscore dummies, dummies, and it is a function inside pandas library. However, for the newbies here, I would be simply explaining label encoder and how it works, right? And again, you have to understand that using these different variants of encoding can impact the model and its accuracy also. While we are actually learning about label encoder, I would also tell you where you can use label encoding and where you should not be using label encoding, right? So the first thing is explaining the label encoder. Now, label encoding in Python can be achieved using sklearn library. So sklearn provides a very efficient tool for encoding the levels of categorical features into numerical values, where the values are between 0 and the number of classes minus 1. Meaning, let's say that for the first column, the categories are E and P, and as you can see above, E and P are edible and poisonous. So there are two classes. So the values representing E and P will be 0 and 1. That is 2 minus 1. Number of classes minus 1. Right. So for each of the columns, the numerical representation would be from number 0 to number of classes minus 1. Okay. Now, if a label repeats its assigns, the same value to the assigned earlier is being done. So basically what happens is it understands the number of columns present and the number of categories present, and then starts assigning numbers to each of those categories and replaces all of these text data in from numerical data. Okay, so as you can see now, what I've done is I built a function and which takes the mushroom, or I would say the columns from each of the mushroom data set, and what it does is first calls out the label encoder class, then fits the column, and once it understands all the categories present in that column, it transforms the column into the form that is numerical representation. Now, not only this, but we can also, just simply print it out, the name of that column and the classes it has present. So what I have done is I used a for function and again calling this label encoded function for each of the column present. And as you can see that all of the column names with the categories are represented here. And this is a simple example of what the label encoder has done. So for the second column, yeah, this was the second column, right? Yeah, the second column, there was B, C, F, K, S, X. So all of these categories were present. And now these categories are represented by 0. So for B it is 0, for C it is 1, F it is 2 and so on, right? And even if I use again the function head function on the data frame, you can see that the values are not E and P, it is 1 and 0, and similarly not B, C, F, it is 5, 0, and so on, right? And as you can see, for each and every column, the values are in numbers. So this was label encoding. And what about one-hot encoding? So one-hot encoding again, what it does is it extracts the categorical data and creates new column just like get dummies. But there, what happens is that let's say, yeah, let's say that the first was class, right? Class column. Now it has E and P. What happens is that this class column will not be present, but there will be class E and class P. Two new columns will be created and the values present inside them will be 0 or maybe 1, and similarly here also 0 or 1. Let's say the first data point or the first row had the class E. Okay, so what happens here is that the in this column class underscore E, 1 will be present, and in this column 0 will be present. So likewise, in this way, two new columns were created and the value was represented by 1 and zeros. Now, what happens if we use one-hot encoding for each and every column here? Since each and every column here present is actually a categorical data, right? So what happened will be that we know from the start that we started with 23 columns. But if I start using one-hot encoding, it will create new columns for each of the existing columns, and the number of columns will increase to a point where we will be actually having problem because of the increase in dimensionality. And the more dimensions you have in your data set, that is the number of columns you have in your data set, the more expensive it becomes for the model to train and the more time consuming it becomes to model, so that the model will be able to fit properly on the data. So that is the reason why for this data set we haven't used one-hot encoding or a function called getDummies, but we directly used label encoder and started moving on to feature engineering and exploratory analysis for the data. So this was the reason why one-hot encoding was not used. But let's say the data had maybe just two or three categorical data columns. Then we could have used categorical data, sorry, we would have used one-hot encoding rather than the label encoder. Okay, so the next thing is, yeah, so the next thing is we will be understanding a correlational graph, which I will be explaining to you in the next part. So, right here, we will be understanding about the correlational graph and why we need it. So, what is a correlational graph? Now, actually, what is correlation? Here you can see I've used the data frame and the function core, and using the SNS, that was the cbond library and the heat map function that builds me an heat map for the correlation. Now, as you can see, each of the classes are represented on the x-axis and on the y-axis, both ways, right? And some numbers are present. Here, a scale is also present that says that the value might be minus 0.5 to 1. So what is this? Now, correlation is basically telling you how influential one column is onto the other. As you can see, let's say this is the class column, right? This is the class column, and the second column here is cap shape. And if you see a value that is 0.053 present here, but for class and class, we have a value of 1. So from this, you can infer that if there's a change in class, there's a change in class. Yeah, so this is not exactly explaining much, but what I want to tell you is that if there's a change in class column, there's going to be a 0.053 times, not exactly times, but this amount of change in the cap shape column. That is, if there's a correlation between A and B columns, right? For example, then if there's a change in A, there would be a change in B. Now, how much change is going to be converted from A to B is what correlation is telling you about. A value of 0 to 1, right, will tell you that there is going to be a positive change. A value of minus 1 to 0 is telling you that there is going to be a negative change. So what I'm looking out for is that if if there is a column that is actually influencing the class column, if there is, that means that that column is a very important column because changes in that column directly influences our prediction column, right? So that is one reason why I would be building this correlational graph. And as you can see that for this class column, there's a value of 0.54 for the column guild size, meaning that the guild size is very much influential for the class. It might happen that a large guild size means that that is a edible one, and that a small guild size means that it is not an edible one, or vice versa. Whatever be the case, you can see that the guild column is very important for prediction of our class. So whenever we are looking out for, let's say that I have to reduce the dimensionality of my data set, what I would do is just build a graph, right? A correlational graph. And I would look out for all the columns that have high correlation, maybe negative, maybe positive. But if the values are closer to 1 and minus 1, then I would put those columns and remove the rest of the columns to reduce the dimension. So this is one way you can understand that how one column is able to influence the prediction column, right? For us, that is the first column, that is class. So this was why a correlational graph is built and how you can infer from it. Okay, and you might be thinking what this wheel type is, because it is blank for both the y-axis and the x-axis, right? So why is this occurring? So let me tell you. A correlational graph is actually calculated with the help of standard deviation or variance, okay? And there's in the wheel type, there's only one type, okay? Because there's one type, there's no variance in the data column. That's why it is empty. So next you can see I'm just categorizing or actually removing the prediction column and then dropping that column from my main data frame so that I can now build the final data set that would be fit into the model. But before fitting, what we are doing is using PCA. Now, what is PCA? So, PCA is Principal Component Analysis, which basically does is that it will help you in reducing your dimension in other way. Now, before what we did was find out the correlation and remove these columns. Now, what PCA does is rather than just removing the column, it starts merging the column in a way, okay, and then it reduces the columns or the dimensionality of the data set. And as you can see here, there's a parameter that is n components, and I've given the value 7 and then I'm giving the value 15. Now remember, we started off with 22 columns, right? The 23rd being the target column or the target variable. So I use the function fit transform, then it fits the data, okay, and after the fitting, it fits the data and then transforms the data, meaning that you fit the data inside this PCA and it takes on the input as the 22 column data set, and then it transforms the data set into a 7 column data set, which is now stored inside the PCA fit. So I've done this for both 7 columns, that is the final data set will be having 7 columns and the final data set would be having 15 columns. Both are stored in PCA fit and PCA fit 2. Now I'm using the train test split function to split the dataset into testing data and training data. The test size is 0.2, meaning that 20% of the data will be test data. The next you can see is the random state, meaning that once the data is now stored in here, before storing we will shuffle the data and then store the data into these variables. I'm calling the random forest classifier with estimators as 300. The number of estimators are 300, and n jobs is equal to -1 is telling that all the processors are to be used for training the model. Now fit the model here and you can see that it is giving you an accuracy of 100%, which is well and good, and even the testing accuracy is 99.75, which is again very good, as I would say that it is, since it's close to 100, it is already predicting all the classes that are accurate and correct. But what you can even try out is that rather than using the transformed data set having only 7 columns, right? As you can see, the data set I've used is PCA fit. What you can do is insert PCA fit 2 right here. You can insert the PCA fit 2 and see if there is a change in accuracy or not. And let me tell you that there will be a change in accuracy, and this accuracy might turn out to be 100 or even 99.9, right? This is because that while you're trying to reduce the dimensions, it doesn't mean that all the information which 22 columns stored are now stored in 7 columns. Some information is left out, or maybe some information is actually lost while the transformation of the 22 columns is being done. So there is a trade-off. It is not like a totally overpowered that you just give any number of features to it and it would reduce it into a very less amount, right? If it has to be done, then there's going to be a trade-off that some information is lost, and because of that there can be a little bit decrease or downfall in the accuracy. But again, 99 is pretty good, so we can directly use that PCA having these 7 components, right? And now the last thing that I'm doing is saving both the classifier model that predicts and the PCA model that transforms the data. Now both of these are stored by using pickle. So the pickle library has a function dump where you give the instance that you want to save and the place or the path where you want to save. So with this, we have completed the first part, that was building our machine learning model. And then we will move on to the second part, that was building the second part where we will be building the Django web application. Now, before understanding what the code is and how the application is built and run, let's first understand what Django is. So Django is a Python-based free and open source web framework that allows the model template views, architectural system, or pattern. It is a web framework that has a set of components that helps you to develop websites faster and easier. Now, even if you haven't understood what model template views is, then let me tell you that Django has three major components. One are one is the model, that is the database that you're going to be using to store or retrieve the data and showcase maybe on the site or maybe retrieve from the site itself, right? The second is the template, that is the front end part. It is basically defined by an HTML page where you might be using CSS or other things to visualize or beautify your front end. But the template basically means that a page where you're maybe showcasing your data, or either you're retrieving the data in the maybe in the way of filling up of forms or maybe filling up of details and then storing that data in your models, that is database. The last part, that is views. So views is the Python file where each and every function is run, and functions are uniquely defined in such a way that each template is using one function respectively, and that function is helping in rendering of that template onto the server. Now, this is again, it might be a little confusing or complex to understand. So I would be showing you the code and maybe it will clear out some of the complex part that I've just explained. But before that, simple things that you have to do is that first create a project, okay, a project directory where you're going to store this code. Second, build an environment for this project directory. Now, if you're using PyCharm like me, it is very easy to build a new environment. All you have to do is go to the settings, and in settings, go to the project interpreter that would be present inside your project and the name of your project. And then you can see that a project interpreter is specified here. So what you have to do is just click on add, okay? Or if you already have an environment that you want to use, just then click on here and that environment would be present here, okay? So click on that environment and then environment will be loaded. Once you do that, click on apply and then okay, right? But now you already have an environment, but an environment doesn't have any of the dependencies or packages that are going to be used by this code or this Django application. So what you have to do is first go inside the my site directory in the terminal like I did. Now you can see that I'm inside my project, then inside the my site directory. Now inside my site directory, all you have to do is run this code here, right? Once you run this code here, all the packages and dependencies that are required by this project or this Django application will be installed and stored inside your environment. So once you do this, now the environment is built, the packages are now set, and this code now can be run. So you are now able to set up the code and the packages that this code requires or this application requires. But now you have to set the application itself. Okay. So for that, what you have to do is again inside the my site directory only in your console, you have to run the python manage.py migrate. Okay. So once you run this code, what happens is that all the pre-existing models that were built by Django to run the Django application smoothly are going to be instantiated, and the data that is required by the Django application itself to run properly will be stored inside those databases or the tables inside those databases. So for that you have to run the python manage.py migrate. There are many functions that are specific to Django, and one of them is the migrate function. So whenever you have to run a code that is specific to Django, what you have to do is write Python manage.py and then the function. Now these functions are actually defined inside Django, I would say the Django package only, and there are many functions that are present like migrate, make migrations, run server, sync DB, and many more. But for this project, all you have to do is run this. And lastly, when you have set up the code properly and understood the code, what you have to do is run this. So this is the function run server, and what it does is it starts the development server on your local machine, and then you can go onto the site and see if the site is working properly or in a properly fashion that you wanted it to. So moving forward, first I'm going to show you the settings page, right? So this is the settings page that is present inside your my site directory. Now this my site is actually inside my site directory, so don't be confused, okay? So this is the project folder, as you can see, the project folder, and this is the app folder. Now project and app are different because app helps in building functionalities onto the site, but project helps in maintaining your site, right? So all the important functions that are to be run by Django applications so it is able to run smoothly, or to maintain or to connect maybe databases, to connect maybe other softwares or other services like maybe AWS services. You have to set up those inside the settings.py file inside your project folder. So as you can see that the allowed hosts are already set here, right? So this is for the local host when you are developing your website and running that website on development mode, or you're running the site on locally, right, on your local machine. And this is when you're running the site on your server that is present on the that is present actually in a web server, right? Then you can see installed apps, and there's an authentication, there's content type, there's session. So you can see that Django is already giving you a pre-built site where it is already handling the sessions, the authentications, and the static files. You will understand what static files are. And so you can see that the Django is already able and capable to handle all of this without your intervention. Now you can maybe either update these, maybe, sorry, these sessions, or maybe the authentication, how authentication is done, but that is totally up to you. And if you don't know how to do that, Django is already giving you a base on which you can directly use the authentication rather than building one from scratch. Next, you can see that here databases is present, meaning if you're going to, yeah, if you're going to store or if you're going to connect any databases or services, then you can change the values here or update the values here. And lastly, you will be looking at static files. So you can see that static files are maybe images, JavaScript, CSS, right? So all of these are considered to be static files in Django. And static files are also stored in a separate folder and accessed from there by Django. And to build that folder, you have to create a static root, and to access or help Django access, you have to create a static URL. So even if this is not totally understandable or it is confusing in any manner, you can directly go to the Django docs, and it is actually pretty easy to understand. And from there, you might be able to get to know more about how this code or application was built and why some of the functions that are present here and what do they do. So next I'm going to show you is views. Now as I told you that Django was a model template views or has a model template views architecture. So this is the views Python file which is actually present inside your apps, right? So this Pulse is an app which has the views Python file. So what happens is you create a function, right? It takes the parameter request, and then Django understands that this function is capable of rendering one HTML page, right? And as you can even see, if you scroll down, there's a render function which helps in rendering the index.html page. So this function is maybe mapped to this HTML page. So once you run your project, or once you locally run your project or website, what happens is this function is called, and this function, when called, renders the HTML page. So this is the HTML page present here, and as you can see, this is just the CSS. And if you scroll down, you can see that a form is being created. Inside that form, we are taking the values. So what happens is that you build a form, the form is filled, and once you click on the submit button, right? Once you click on the submit button, so here's the submit button. All of that data, which was just now filled, goes into the views, and inside the views, I'm storing it inside different variables. Now what I'm doing is, once I've stored the actually values in each of these variables, I create a data frame. Okay. Once I create the data frame, then I just use my PCF to transform the data, and then I load the model that was the random forest classifier model. And once I load that model, I use its predict function to predict the data, that is, if the mushroom is edible or poisonous. Now, as you can see, once this data frame was created, like you can see that each of the variables that I had above is now converted or typecasted into int or maybe float type, and then stored inside your data frame, and that data frame is then sent to the PCA model, and that PCA model is transforming that data, meaning that this 22 column dataset is now squished down to 7 column dataset, and then that 7 column dataset is loaded into the, I won't say loaded, but fit into the model, and the predict function then predicts if the class is poisonous or edible. Now it predicts as 0 or 1, so you have to understand 0 represents edible, 1 presents poisonous. So once I'm able to, get my result, what I'm doing is I'm sending the result back to the front page with the help of context. So this is called context, which is in the form of dictionary. Okay. And even if you be watching this, yeah, if you can see this, I be also predicting, not predicting, I also showcasing the prediction that if response is present, then you have to show this H2 line that the mushroom is the response, that was if it is edible or poisonous. Now this is how the template views is working. Now the last thing to understand is that how is the function being called. As you can see, there's no function call present inside this page, right? So how the function is called. Now the function is called with the help of urls.py. Okay, not this one, actually this one. Yeah. So you can see that what happens here is that a path is associated with the function. Okay. So whenever you go onto that path in your browser, this function is called. So this is how this function is called. And once this function is called, it takes or it renders the HTML page, takes on the value that was submitted by the form, uses that data or manipulates that data into getting the result, then again sends back the result. So let me just locally run this, and it might be better in the form that you will be directly able to understand how the page is working. So this was the Django command to run these or to start this server locally, and it gives you the localhost URL, where once you click on this, the page will be loaded, And as you can see that a lot of columns, or I would say a lot of data has to be now inserted, and once you insert and click on submit, the prediction will be done. So this is the second part where we were developing the Django application and mounting our prediction model. Now the last part is developing or deploying this Django application on Heroku, right? So we will be looking at the Heroku part in the next video. This is the third part of the project where we will be deploying our web application on Heroku. Now before we start with Heroku, we have to use some files which are like command for Heroku to understand while setting up the code on its server. Now let's start with runtime.txt and proc file. So runtime.txt is basically just telling Heroku which language or base is to be used by the server. And even here, as you can see, that it is telling that Python is to be used and the version of that Python module. So the next is proc file. Now what is proc file? Proc file is a mechanism for declaring what commands are to be run by your application in Heroku platform. The commands that are specified in the last part, like run server and migrate, these commands are executed in Heroku server using the proc file with the help of WSGI file that is present in your project folder. So with the help of both of these files, Heroku is able to understand and set the code onto its server. But both of these files are helping the setup of the code on the server. But what about the dependencies or packages? For that, you have to create another document that was requirement.txt, where each and every package and its version, I would say, yeah, its version, all of that is stored. And with the help of this, we are able to download and install each of the packages that are required by this application. And like we just typed in pip install our requirement.txt, similarly similarly Heroku also automates that and takes on the packages and its version from the requirement.txt. Now what you have to do first is go to GitHub, right? Inside GitHub, go to your or make a new repository. Since I've already built a repository, so once you go there, so yeah, here you can see that I've stored my files or my code in this repository, right? And here you can see my site polls and all of that is stored here. And here you can see that there's an environment and it is active, meaning that this repository is actually connected to a app on Heroku, and that app has now virtually using using these files is able to run a server on which these files are present, and the website is now active and running on that app in Heroku. So first you have to store your code inside the GitHub repository, and once you do that, you can just go to the Heroku platform and log in into the Heroku platform. So once you do that, you will be able to see the dashboard. Since I've already built some apps, those apps are now listed here. But for you, what you can do is click on the new and create new app. Now, once you click on that, just type in your app name, choose the region, and then click on create app. So once you do that, that app would be listed here. As you can see, I have built an app named Mushroom class. So this app, since it is already active, I will show you what I did to make it active, right? So first you can go to the settings. Once you click on settings, scroll down and there's a build pack option. So click on add build pack and then click on Python. Once you click on Python, click on save changes, and then that build pack will be shown here. You can see Heroku/Python. Now go back to the deploy option. Now in deploy option, there are three options for deployment. you have to choose the GitHub Connect. And again, I'm telling you, this is the easiest way you can deploy your code. So click on GitHub Connect. Once you click on this, it would ask you to log in and using your credentials to GitHub. Then once you submit your credentials, then it will ask you to connect one repository to this app. So you have to first search the repository name. Then once you search it, then it will give you an option of connect. So once you click on connect, it would then show you that SITP mushroom class, that is the repository by the account, is now connected, and there's an option to disconnect this also. The next thing to do is go to the manual deploys, choose the branch in which your code is present. Since my code was present in the master branch, I'm choosing the master branch and click on deploy branch. Now once you click on this, the automation done by Heroku starts, where it starts to automatically store in your code and set up your code on the server with all the packages and all the static files, so that you can directly now run your website on this Heroku platform only. And if you scroll up, you can see that the Python version specified in runtime.txt is what the Python module is now loaded onto the server. Next, you can see that it has installed that version. Then using the pip, it is installing all the here requirements with pip. It is installing all the packages that are required by this code or this application, and then it is running the collect static dash dash no input. This is a Django command which helps in storing all the static files into one folder. That was the static files folder we specified in our settings.py file also. Next, it is releasing or launching your web application onto its server, and once it does that, it gives you a view button. So once you click on this, your website is now live, right? And you can just take for once, put in all the info so to see if the if the website is running correctly or not. Yeah, this is taking time. So my god, there are a lot of columns. I'm just inputting anything, right? I don't know even there is a mushroom with all of these specifications or not. Finally, so click on submit, and then it starts to predict, and as you can see, the mushroom is poisonous, right? So with this, we have completed this project where built the machine learning model, mounted the model on our Django application, and lastly deployed that application onto Heroku.